Okay, welcome to the Git session. We're gonna get started learning Git, and there's gonna be a lot of puns probably along the way. Um, so yeah, Git is what's called a version control software, which it it's like an app that runs on your computer. It's some software that runs on your computer. But unlike the apps that you're usually using day to day, it doesn't have like an icon. You don't double click on it to open it. It runs kind of it runs in your terminal. So it's a set of commands that you can run in your terminal. And so we're going to be doing terminal stuff, running commands, and it's going to be great. Uh, it can be confusing, but I prepared some slides and we're going to hopefully demystify it for y'all. Um, and before we get started, I'm just gonna open the floor up to if anyone has any specific questions they want answered, and I'm also gonna check if there was any on this post. Looks like there wasn't. So yeah, if anyone has any like specific topics they want covered, feel free to drop those in the chat or just hop on the mic and let me know. Cheat sheet for Git. Yes. Actually, I'll give you all I have a cheat sheet and a guide and a bunch of stuff. So I made this Git guide. So Git guide. I made that, and in there I linked to this cheat sheet that I made. I'll also just link that separately too. Git cheat sheet. I spent like 100 hours on that cheat sheet because I got carried away with designing and stuff. But that should be everything you need to get started with Git, um, along with this recording, hopefully. And also my slides. So I will export these slides. Um, let's see, file type. Let's do a PDF. And Git slides. Sorry, I just got back from a dog walk. I had to like rush back, and I did prepare for this, I promise, even though it doesn't look like I did. Uh, okay. So I'm going to post in the Kepler announcements Slack channel. Uh, here's the slides. So you all should have a copy of these, and then I'm going to screen share finally, and we can get started. So looks good. Okay. Can everyone see my screen?
Yep.
Yes, cool. Um, this is my first time using Figma as like a presentation software. I use it for design. You can like design application UIs and websites and stuff, but they just introduced this new slides thing as part of it, which is cool. So I'll be trying that. Um, oh, sorry, all the way back to the beginning. Okay. Okay. And throughout this, if anyone has any questions, feel free to just yell at me and let me know, or drop it in the chat. I sometimes forget to look at the comments, so I'll try to remember. But if it's urgent, or even if it's not, just if you have questions, don't hesitate to bring it up. I love like answering questions, that's why I'm here. So, um, okay. So Git is a version control software, which basically at just the most like high level, you can think of it as it helps you keep track of your code by saving checkpoints throughout time. So kind of like when you're playing a video game and you like save the game And in a lot of video games, you can go back to previous saves. It's like different checkpoints throughout time. And so you can do the same thing with your coding projects, which is really nice because when you're writing code, a lot of times you are dealing with, uh, the big real like world of coding. There's a lot of projects that are thousands, even millions of lines of code, and there's hundreds of people working on them. And it's really important to be able to keep track of, the state of the code base at like at any time. And then, so that's one really great thing that Git does is allows you to save your place. And if you introduce like a bug or, you make some change that you want to revert, you can go back to a previous state, and it's nice because you have that like history. So there's this whole workflow you get into while you're writing code with Git where Git will be watching over your project and keeping track of your changes. So anytime you're making changes in code, you're going to be storing them using Git, and then you can always go back to a previous state. And when you're working with other people, and just in general, you'll use this thing called GitHub, which GitHub is like Git, but it's on the internet. So GitHub is a website, and these two are often confused, Git versus GitHub. So Git is the software that you use to keep track of your code. Um, Lets you save your code throughout time, like checkpoints. And GitHub is a website that allows you to store your code. So you can go to GitHub. I'm thinking all of you have GitHub accounts already, or at least I'm pretty sure that was like one of the beginning prerequisite things you did at the beginning. But if not, that's fine. You'll just have to do it. Go to GitHub, make an account. It's just like a website. And so on GitHub, you can store your code, and it also keeps track of the Git status. So you can see like the history of your code. You can go back to previous points and look at it. You can see other people's code, and it allows for other people to like share their code and even have multiple people writing code within the same code base. And Git helps you keep track of your code, and GitHub helps you like have one central place that you store the code. And you go, the version that's stored on GitHub is the official, source of truth version of our code. And then when you want to work on it, you make a copy of that code on your own computer. Um, so you clone the code down from GitHub onto your computer, and then you make some changes, and then you can push those changes up to GitHub. And sorry, I'm getting a little bit too into the details for just the high level overview, but there it is. There's the high level. Git helps you track your changes of your code throughout time and easily collaborate with other people. And Git is a software that runs on your computer. GitHub is a website that is used to store Git repositories. So store your code on Git or GitHub, keep track of it using Git. Okay, and I probably covered half of what's in these slides already. Git lets you save versions of your code through time. So uh, you can see this is like your code through time, timeline, checkpoints. Each time you save your place, you make a commit. So that's going to be the first kind of big terminology besides just Git and GitHub. Oh, oh. So first piece of terminology is commit. So when you want to save your place, you make a commit. That's what it's called. So there's actually a command that you will run in your terminal. And by the way, everything I'm showing you, I will be demonstrating. So I'm going to start with these slides, and then I'm going to actually go and do all this stuff. So you'll see it. But yeah, commit is kind of, that's the action that you take when you want to save your place. You commit your code. Um, and it kind of makes sense semantically. You can think like I'm going to commit to these changes that I made since my last commit. So what your Git history will end up looking like is a bunch of commits. a series of commits, and those are each time you decide to save your place. So commits are like snapshots of your code at a point in time. So you can write some code, make a commit, and then if you want, you might be able to go back, or you can, you can always go back to a different commit in your history. So if you wrote some code that broke your whole thing, you can always go back um, to a previous commit. And um, I made some slides that are like the actual command that you write in your terminal. So a git commit is this command right here. So you'll write git commit -m, and then in quotes, you write a message. And that message is just for yourself. It can be whatever you want, or for whoever else might be looking at your code. Um, the message is just saying, what did I do in between now and my last commit? So you'll typically make a commit each time you make a significant change in your code base, or just anything that like feels like, okay, I'm gonna put a bookmark on this, code right now. So you might say, added a button. That could be your commit message. Um, and so yeah, you commit and then you add a message so that you can identify it, so that you can like find it later and see what it means. Um, okay, the next big one, branches. So far we've been talking about Git as if it's just one timeline with a bunch of commits, but you can actually have different branches. So different versions of your code that are like kind of stemming off of one common ancestor, but they have some, they kind of diverge at some point. So uh, the typical use case of branches is um, you have different people working on different versions of the code. And so say one person's adding a button and another person's adding a photo to your website or whatever. Um, one person might be on one branch, another person's on another. And then when you want to kind of integrate those changes in with kind of the main source of truth, you'll do a merge. So yeah, you can work on your code uh, on a branch, and yeah, branches. They help you to collaborate and experiment. So experiment meaning if you have your code at a certain point and you're like, I'm going to try something, but it might break everything, that might be a good time to make a separate branch, because you might just go, this is where I branched off and potentially broke everything or made everything great. If you want to like, you know, separate the series of commits you're making, you can make a branch. Um, and this is the command you run for a branch. Or to make a new branch, you say git checkout -b, and then in quotes, the new branch name. So the reason it's checkout is because there's a command called checkout, which allows you to check out, like you can use checkout to revert back to a previous commit or to make a new branch. It kind of does a lot. And um, so you're checking out a new branch. Um, and so it creates a branch and switches to it. There's actually technically two commands that you can run. There's one that you can make a new branch, and then there's one that you can switch to it. But the easier way is usually when you make a new branch, you want to switch to it too. Because you always have one branch kind of checked out at a time. And so if you make a new branch, it's likely you want to switch to it. So this will do it all. Creates a new branch and switches to it. Okay, another command, two more actually, Git status and Git log. So Git status is a way to kind of view your current state. Um, and then Git log is a way to see your history. So Git status says, what branch am I on? Do I have any uncommitted changes, etc.? And then Git log says, show me my commit history. So if you want to go back to a previous commit, you would run git log, because git log shows you a log of all of your previous commits, which again are like checkpoints. Okay, next is git add. So git add, you run git add and then you specify which files you want to add. Um, this is probably the first one that like isn't very intuitive so far, I'd say. Um, when you're working in Git and you save your place, it doesn't automatically save all of your files in exactly the state that they're in. So when you do a new commit, it doesn't go through and go, okay, here's the exact state of all of your files. I'm going to save these in their exact state. First, you have to stage all those changes. So basically, you have the option to say, I want to include these changes that I made in this commit, but I don't want to include these other ones. And so git add is what you use to stage your commits or stage your changes for a commit. And then the dot means stage all changes in this current folder that I'm in. Because when you're working in the terminal, you're always in a specific folder. So git add dot will save, or it'll stage all of the changes for your next commit. So the work or like the flow there is you write some code, you run git add dot, which stages your changes that you make. And this stages all of them. And you typically want to stage all of the changes. It's very rare you only want to stage some, but not the others. So pretty much don't worry about the fact that you can stage individual files if you want or leave some out. You pretty much always want to stage all of your files for the next commit. So yeah, you write some code, you run git add, which stages your changes, and then you run git commit, which saves them, and then you're good. You saved your place. You always run git add before commit because you stage your changes and then you commit. Okay, new terminology, repository. So a repository, also called a repo, is a folder that Git is set up to track. So Git doesn't automatically just run on all of, like, it doesn't watch over all of your files on your computer by default. You have to tell it, I want you to start tracking this specific folder. And so far, you've been working in Code Sandbox, which in Code Sandbox, you're not dealing with the actual files really themselves. You kind of are. You can see them in your side panel in Code Sandbox. But uh, after this week, actually starting this week, you're going to be working on your own computer and not in Code Sandbox anymore. You're going to be, making your own files on your own computer instead of on Code Sandbox, which is making them on the internet over the cloud. So, uh, uh, like what actually is a what a code base is it's a folder with a bunch of files in it, and all those files are code. So every like coding project has kind of a root folder that you're storing all your code in, and when you set Git to track that folder, uh, you can now call that folder a Git repository or a repo. And I don't really know why. So, oh, I think a lot of the terminology and coding stuff is kind of dated. It was made like 30 years ago by nerds, and so they decided to name it weird things. So yeah, we end up with words like repository, which you can just think of it as this is the folder that I'm tracking. Um, and pretty much from now on, you'll call any coding project you have a repo. That's just the word that people use. Because pretty much everyone uses Git if they're going to write some code because it makes it easy to not break everything. Um, okay, so this is how you make a new repository. So you have like You have your code files or your folder that you want to like start tracking with Git. You run git init in that folder. So init, short for initialize. So this sets up Git to start tracking changes in the current folder, and any folder being tracked by Git, which I just said like 10 times, it's a Git repository, also called repo. So this is the first thing you're going to run when you make a new Git repository. Except for today. Today we're going to be making them on GitHub first and then pulling them down to your computer. And in that case, which is what we're doing today, you don't actually have to run this. This is if you're making it on your computer first. But yeah. Okay. More terms, local and remote. So uh, you'll generally have a local and remote copy of your repo. So local means this is the folder that's on my computer. Remote means this is the folder that's on GitHub or anywhere on the internet, basically. GitHub is not technically the only place, the only website for storing code in Git. There's other ones. There's one called GitLab and a few others, but really no one else uses the others. Or other people do, but GitHub is by far the most popular, and we're going to be using GitHub. So you have a local version of your code, which is a fully different copy. They're the same code technically, but if you are writing code in your local folder, your local repo, then the one on the internet is not going to get those updates immediately. You have to like keep them up to date, keep them synced if you want. So we're going to be doing all of our work from now on in a Git repository on your computer. And then when you want your code to be reviewed each week, you're going to push those changes to the remote version on GitHub so that your reviewer can see the changes you made. You can see like, this is what I did for this assignment. So yeah, local your computer, remote is GitHub or any internet thing. Okay, push and pull. So these are commands that allow you to interact with that remote repository. So the version of your code that's stored on GitHub on the internet, these commands you run on your computer, and uh, they allow you to either pull changes that are like if someone else made changes and then they pushed them onto the remote, then you'll need to pull those changes to get the latest version. If you made some changes, you'll want to push those changes. So you push your changes up to the remote, or you pull your changes, or you pull changes from the remote to your version. So these are ways of keeping your code and the version that's on GitHub in sync, because they're not going to automatically just be exactly the same. If you make some changes and you want to like update the version that's on GitHub, you need to push those changes. So these are for uh, updating and syncing your local and your remote version of your code. So you push changes to GitHub and you pull changes down from GitHub. And a caveat, which I'm pretty sure they don't say this in the Code the Dream like curriculum right now, which this trips up a lot of students. So um, I'm gonna request that they fix this, because when you run git push, there's actually another thing you need to add on to the end. You need to run git push -u origin and then the name of the branch that you're pushing. So git push -u origin of branch. And I have this command fully like in the cheat sheet that I linked and uh, in the guide that I posted. And I'm going to try to update the curriculum here to always mention like if you're going to run git push, you need to run this. And the reason git push does work on its own, but it's only if you have a branch that already exists on GitHub. But if you make a new branch on your computer and it's not on GitHub yet, that's when you need to run this one. You need to run git push with this added stuff that says, I want what's called the upstream branch, which the upstream, that's the remote, or the upstream is whichever one doesn't have the most recent changes. So you need to add an upstream uh, origin branch. I don't know. There's a lot of jargon here. Don't worry about it. Just know, sorry, just know run this. And name of branch, that needs to be different. So when you make a new branch each week, because that's what you're going to be doing, you're going to make a new branch each week and just replace name of branch with the name of your branch. Okay, I'll pause for a second because I just gave you a lot of information and I want to make sure you're absorbing it. How's everyone feeling? Does anyone have any questions, comments so far? I'll take that as a no. Okay, we'll keep going. So, uh, this is, I'm going to show you the kind of workflow for, I just showed you all these commands, but you're not going to intuitively know right away necessarily like when to run them and all that. So, uh, and it's going to take you a while, just so you know, to feel like comfortable with all this, and that's totally fine. Git is confusing. It's confusing for everyone. It's like a rite of passage when you're learning how to code. Every developer has to learn it, and every developer has a hard time with it. It's not intuitive or easy for most people to learn. So I'm gonna try to break it down, and basically you just need to have this information repeated multiple times, and then you'll start to get it and uh, have practice with it. So I'm gonna start with the most basic version of your workflow that you're gonna be doing with Git, and that is just this. This is you writing some code, and then you save your changes with Git. And then you just write some more code, and then you save your changes, and you write some code, and you save your changes. Uh, that is the most basic workflow you could have. So that is you working on your own computer with your own code. You're not saving it on GitHub. You're not sharing it with anyone. You're not making branches. You're just saving your place. That's the most basic workflow. And sometimes you'll do that. I do that on projects if I'm not trying to uh, have it be a whole thing. I'll just write some code, just save my changes with Git. So that's the basic workflow. And okay, here is the workflow that you're going to follow using GitHub. You're going to write some code. You're going to save your changes with Git. So those are the same. But instead of just writing more code again, you're going to write some code, you're going to save your changes with Git, and then you're going to send those changes to github.com. You're going to say, I made some changes and I want the version of my code, the repo that's stored on GitHub, to have those updates. So, yeah, write some code, make a new commit, which save your changes is making a new commit, and then pushing to GitHub. And then your reviewer is going to review it on GitHub. So that is how your reviewer from now on is going to be like you're going to be doing your assignments using Git, and your reviewer is going to be able to see the code that you wrote only if you push it to GitHub. So you're going to push it to GitHub, and then your reviewer can see it because it's on the website. And they review it, and then hopefully they approve it quickly. And I know that the reviewers don't always, I'm trying to get them to, they're volunteers. They're doing their best, but they'll review your code, and then when they're done, you'll just write some more code. But technically, there's a little bit a little bit more to this workflow, so we'll see that in the next slide, but this is kind of the high level overview. You write some code, save it, send it to GitHub, get it reviewed, and then move on to the next week. So you're going to do this every week. And also, just so you know, all this stuff we're going through, this is not just here at Code the Dream. This is like all programmers everywhere. This is like most of this stuff applies to uh, the real world more than anything else, like the actual jobs in coding. This is what they're like. Uh, at your job, you are, contributing to a code base that is on GitHub, and everyone on your team is using Git to manage their code. And that's why we're doing it here, is because it teaches you that like real, tangible um, skill that you're going to need if you want to be a developer. So, okay. So this is the same thing, except there's a little bit that I hid from you. This is going to be more the more detailed version of what you're actually doing. You're going to be working with branches. So you're going to be writing some code, saving your changes with Git, sending to github.com. Your reviewer reviews it. These are all the same. And then after your reviewer reviews your code, you're going to merge the branch that you were just writing code on, which you're not going to write branch on the same, or you're not going to write code on the same branch every week. You're going to make a new branch every week. After your reviewer reviews that code, you're going to merge that branch into your main branch. So you always have a main branch. And so yeah, you merge into main once it's reviewed. And then on your computer, you're going to pull the updated version of your main branch. So your main branch is going to get like updated with the changes from that other branch because we merge those branches. And then on your computer, you're going to pull the changes onto your main branch, the merged version. Um, and then you're going to create a new branch and start it all over. So what you're doing is you could imagine you're keeping your main branch up to date by every time you write some code, you're writing it on a new branch. And then after that code is reviewed, you merge it into main on GitHub and then update your local version of main by pulling it. So it's kind of this weird thing, this weird workflow where you're working with a new branch each week, and then you're merging that branch into the main branch on GitHub, and then you're pulling the updated main branch onto your computer. And then you're splitting off a new branch from that updated main branch. That's what you're going to be doing each week, if all goes according to plan. And a lot of students, will mess parts up, but it's fine. Uh, it's not a disaster if you are messing this stuff up. Actually, it is, unfortunately. It really genuinely is. It's really, yeah. Git is not easy. It's not like forgiving when you make mistakes. Uh, you'll get into these states where you spend a long time trying to figure out what to do. And so you will probably make mistakes and you will probably end up banging your head against a wall trying to understand why it's not working. And in that case, feel free to just reach out to me or any of the mentors because ideally we'll be able to help. Um, and okay, yeah, I don't mean to scare you. It's it's not that bad. Just you have to be patient if you do mess it up. You have to be patient finding out what you did wrong. Um, okay, I got something in the chat. Thanks for the heads up. Yeah. Okay. Uh, so going back to the terminology, here's another one. Um, pull request. So A pull request is that part that I was talking about right here, up in the top left corner here. The part where you're merging your main branch or you're merging your new branch into the main branch on GitHub. That part is called a pull request, or at least it's called a merge, actually, just to confuse you more. You're merging those branches, but before that merge happens, you make a pull request. And a pull request is it's it's called a pull request. It should be called a merge request. I don't know why it's called a pull request. Um, it is actually called a merge request on other platforms besides GitHub. For some reason, GitHub decided to call it a pull request, but think merge request, um, even though it's a pull request. What it is you are, and you do this on GitHub. There's no command that you run on your computer in your terminal. You do this through like the actual GitHub website. You click on a button that's like create pull request. And what it does is it compares the new branch that you just made to the main branch that you're going to merge with. It compares those two branches and goes, what are the commits? What are the new commits you made? What are the files that you changed? Like any of the changes that you made that are you're trying to like integrate with the main branch, like any difference between those two, it's going to show you those, highlight them, and allow you to look over them before you actually merge. So it's kind of this like temporary uh, before you merge area where you set up the merge and then it gives you this whole thing where it's like you get to review it and you get to have other people review it so that you can verify that everything's looking good. And your assignment reviewer is actually going to review your pull request each week. So each week you're going to submit a pull request and it basically compares one branch to another branch. In this case, it's your branch that you did your new week of work on. It's going to compare that code to your main branch. And then your reviewer can easily see what new code did you add this week. That's going to be easy to see in the pull request. And it's a request because you're typically on the job, you're asking like the other people on your team, um, please merge this new code. Like I made these changes. Uh, please review these changes I made and merge them into the main branch. And it's this whole thing where uh, developers review each other's code. It's very important. And it's a big part of the job is reviewing pull requests. And you're basically just looking over other people's code and making sure that they didn't mess anything up. Because if they did, then you could potentially be introducing bad code into your actual app or whatever. So the pull request is designed to allow for like a review process before you actually go through with merging your new code. Um, sorry, that was a lot. Maybe I'll just read the slide. Before merging two branches, review those changes uh, or request someone reviews them. So that's what you're going to be doing. You're going to be your reviewer for your assignments are they're going to be reviewing your pull request, which it's just like that in the real world. Um, okay, this is how you'll turn in your assignments. So when you create a pull request, it actually creates a new like URL you can go to. Like you are going to submit your assignment each week, and the thing you're going to submit is actually you're going to go to your address bar in your browser, like in Google. You're going to go up, you're going to copy that URL to your pull request, and you're going to submit that and say, someone look at this pull request. Did I do good? Um, and yeah, it's pull request is not a Git thing, it's a GitHub thing. which it doesn't really matter that you know that or not. But yeah, pull requests are like they happen on GitHub. Um, yeah, that's it. Okay. And I took a screenshot of pull request. This is a pull request that I made on one of my random repositories that I have on GitHub. Um, I will do pull requests on my own code, uh, even though I'm the only one who it's like I'm requesting myself to review them. And a lot of people do that. It's just because that's just you're used to that flow of you write some code, you make a pull request. It gives you the chance to look over your code that you wrote and see those changes. So whenever I write code, I usually write it on, uh, if it's a smaller project, I'll usually just make one branch called the dev branch, stands for development, and that's pretty common. Uh, I'll just write my code on the dev branch, and then when I'm ready to like merge a bunch of changes, I'll have a pull request. I'll kind of look over the changes and go, yeah, I think I'm ready to merge these. And on some code bases, you have your main branch. That is the version that's in the wild. That's like the version of your website that's actually out there. Um, so if you uh, change code on your main branch on GitHub, you will directly be changing your website or your app or whatever. So um, yeah, pull requests give you the chance to do that, checking over your code. So you can when you look at a pull request, you can view your commits, you can have comments. So people have like a whole discussion sometimes like, um, hey, this line looks kind of weird. You know, you used an if statement and it should have been a for loop or whatever. And you can comment and say, no, no, it was great. It's working perfect. Um, you can add screenshots. So if you're doing some like front end work, you add a new header to the page or whatever, you can screenshot it and add it in there. So yeah, the pull request is like a little zone for allowing people to chat about this new code that you wrote. And there's a section on GitHub on a pull request where you can actually see the changes. So this is a screenshot I took of that same thing. Uh, so this is a part of the code in my code that I was writing, and it says, here's one of the changes that you made. So this line that has the minus next to it, that's kind of like orangey, this line was deleted. And this line that's blue, this one was added. You can see they're both line 15. And the view when you're looking at like what's called the diff, the differences, the diff view can kind of look weird. And the reason is because, or one of the reasons is because they'll make it look like you have two lines right here that look like the same line, like const h1 equals. This looks like the same line repeated twice, pretty much, right? What actually is happening is it's saying, well, this line doesn't exist anymore, but this line does. Uh, Even though you only changed one part of the line, it interprets it as you deleted a line and added a new line that's a slight variation of it. So that's something that can kind of trip people up, but you don't have to worry about that. That's just, um, I didn't actually delete a line and add a line that's slightly different. I changed a line and it interprets that as this code is gone, this code is there now. It's new, replaced it. So, okay. Getting to the end of the slides here. Okay, so when you're doing a pull request, you write or just when you're coding on a project in general, you write your new code on a branch, typically. You don't write it on, or you're always working on a branch, but you write it on not the main branch. So in Git, you always have like a main branch, and it's usually called main. It used to be called master, but uh, we're getting with the times. We're calling it main now because master is an outdated, potentially offensive word. So we're using main now, which is great. So you write your code not on main. You write it on sometimes dev. That's what I'll typically call my branches. But here at Code the Dream, you're going to call every branch you make the week that you're on. Like you'll call it lesson dash 5 for this week, for example. So that's going to be the name of your branch. So you write your new code on that new branch. And then when you're ready to review that code, or when you're ready to like merge it into the main branch, you do a pull request, get it reviewed, tested. You might have like automated tests that run, which you won't here at Code the Dream, but in the future and down the road, you'll have like automated tests that run that makes sure your code is not breaking everything. And then at that point, you go, okay, we're going to merge this code into main. And so, yeah, this is you as a developer. You're writing your code on the dev branch. Your boss, he says, looks great. He reviews it and or she, and then you merge. Um, and when your boss reviews your code and says it's great, and one of you can hit the merge button, doesn't really matter, but uh, when your code is merged in with the main branch, hopefully it doesn't break everything, but it can, depending on, you know, what code you wrote and what code base you're working on. If you're working on, let's say, some antivirus software that runs on every Windows computer ever, such as CrowdStrike, then your code could potentially um, make every computer in the world break, which, if you weren't aware, there was a big news story about a year ago, I think. This company called CrowdStrike, they have some software that runs on pretty much every Windows computer, or a lot of Windows computers. Automatically by default has some antivirus software from CrowdStrike. And there was an error that they pushed out into production on accident, and their code pretty much broke like millions of computers. So grocery stores weren't working, airports weren't working. Everywhere had the blue screen of death, is what they call it in Windows land. I don't know. I wouldn't know. I don't have a Windows, so I've only ever had a Mac. But uh, the reason that happened is because someone wrote some code and got it approved, and it went into the main branch, and then got pushed onto everyone's computer, and then it broke everyone's computer because it wasn't properly reviewed and tested and stuff. Don't worry, the stakes aren't so high. Here at Code the Dream. You'll be fine. Okay, let's code. But before we code, I'm just gonna stop and ask, how's everyone feeling? Any questions or and technically we're not gonna be coding. I mean, I might write a line of code or two, but we're gonna be doing Git, which is just running commands in your terminal and stuff. Okay, we'll chat. Uh, what would be the steps if you want to work in advance? What would happen if you merge a branch before it gets reviewed? And the assignment needs revisions. Um, well, you already merged it. Yep. So that happens all the time. Ideally, your assignment reviewer is gonna review your code in a timely fashion, and then you merge, you complete the pull request, and then you move on to writing more code after that. Um, but that's kind of the ideal scenario. That doesn't always happen. A lot of times it doesn't. A lot of times your reviewer takes too long and you just want to get on with it. So it's fine. You can you can merge your pull request and just keep writing code, and they'll get to it when they get to it. Um, yeah, I definitely would say don't wait on your reviewer to start your next assignment ever. So feel free to merge your next pull request. There's kind of two ways to do that. The main thing is you want to make sure that when you start writing code for the new week, that you're working off of where you left off. So what you don't want is you don't want to go back to your main branch that's outdated. So the main branch on your computer hasn't, it hasn't caught up with the new updated branch. Um, you don't want to start a new branch from there because that will end up with conflicting histories in your branches and it'll cause a whole mess. So what you can do is either start a new branch directly off. Basically, when you make a new branch, you merge or you create a branch off of a certain branch. I'll I'll pull up a little the branches. So when you make a new branch, uh, technically every branch you make is branching off of a certain commit. And a commit can actually belong to multiple branches, um, technically, kind of, but uh, like two branches can merge into the same commit, basically, or merge off of the same commit. And so when you make a new branch, like for example, this teal person or green or whatever, it's teal. This person, they merged off of this commit right here, which we could imagine this is a commit on the main branch. They made a new branch here, started writing some code, made some commits, and this person in the yellow, they wrote some code, merged their code. Now, if this person who's green, if they want to merge their code, they're going to deal with what's called merge conflicts, which means uh, their code doesn't have the latest updates from whatever is in the main thing. So the version of their code is actually going to have commits where the timeline is there were like two different timelines going on, or three, or whatever. And just like when you uh, are in like a movie and you go into a time machine and you start changing the history, um, it erases timelines in the future, which that doesn't actually happen in Git. But uh, if you try to, you know, merge two different timelines, it can cause merge conflicts. And they're fine. You deal with them all the time, typically in like uh, code bases with other people. But uh, a lot of you will probably run into a merge conflict. And they're not fun. They can confuse you. Um, but if you run into it, just ask a mentor or ask me, and we can help walk you through it, or watch a video on YouTube on it or something. Basically, what you have to do is uh, tell Git, I know there's these conflicting changes, uh, different histories, and we're trying to reconcile them. And you have to go and tell it like which ones you want to keep. So it'll bring up this whole thing in your code editor, and you have to like, I think conceptually it's not that hard to understand, but the actual like interface for doing the process can be kind of confusing and whatever. But anyways, so in order to avoid that, when you make when you do a pull request, if your reviewer hasn't reviewed it yet, either make a new branch off of whatever branch that you had been working on, or ideally merge. Like if your last branch was this green one, merge it into main locally, which you do that by switching to your main branch. And just gonna if that happens to you, then reach out and I'll let you know what commands to run because I feel like I'm gonna information overload all of you. So yeah, okay. I guess just don't worry about it. It's likely you won't run into any issues if you just merge your pull request and go about it like normal. So um, okay. So I'm gonna pull up the assignment and I might try just cruising through it. I'll show you kind of the Git workflow. Okay, so learning objectives and all that, I'm not gonna do that. Just gonna start here. Create a new repository. Okay, so go to GitHub, go to your account, and create a new repository, which remember a repository is a folder that holds all of your code. It's just a folder. But the specific thing that makes it a repository is that it's being tracked by Git. That's what you call a folder that's being tracked by Git, as it's a Git repository or a repo. So I'm going to go and you can make a new one using that command I showed you, git init. But like I said, we're going to actually make one on GitHub. And when you make one on GitHub, you just make it through GitHub's user interface. So I'm on GitHub, I'm on the GitHub website, and there's different ways you can, like you can hit new right here, that'll create a new one. You can create this plus up here. I think you can go to your thing and go to your repositories and create a new one. So there's a few different places, but find the button for creating a new one. I'll just go with this one. Create new repository. Okay, so we're gonna create a new repository. We're not gonna use a template. You can make if someone has like you know, some code that's like a template, like website starter template or something, you might do that. But yeah, for right now, we're not doing a template. We're just gonna have it be an empty repository. And you're gonna call it, oh, what do they want you to call it? Oh, just to note, they do say click the green button. Maybe I'll zoom in a little. They say click the green new button to make a new repository. It's not green in my case. You could see it was up here. It wasn't green because I have the dark theme on GitHub. So everything that's green is blue on mine. Um, but same thing. We created new, or we got to the page to create a new one. So we're filling out a form right now. Fill in the fields to give your repository a name. Okay. So this is important. Get this part right. The name of your repository should be your name dash class name. So your name, you just make it your name with dashes. You can have your first and last. Ideally, you have your first and last. Dash, and then this example is for if we were in Jupiter, but you guys are Kepler, or you all are Kepler. So I'm gonna be Rio dash Edwards, first and last name with dashes in between. So Rio dash Edwards dash Kepler. And it's available because I don't have any other repositories with that same name. You can add a description if you want. Uh, they give you an example. For example, portfolio project for intro to programming course with Code the Dream. I'm just going to copy their example description right here and paste that there. Okay. Be sure public is selected and check the initialize this repository with add a README file. Okay, so it's public and I'm going to add a README file. Oh, check. Okay, and that's all. Now we just hit create, I think, right? Yep. Okay, we did it. So this is my new repository. I know it doesn't look like much, but humble beginnings. Um, on GitHub, this is like programmer central. So nothing on GitHub is going to be really like the most user-friendly thing you've ever used in your life. It's for people who are, you know, they've been working on computers for a minute. So, um, yeah, it's the interface can be a little hard to navigate and understand when you first see it. So just don't worry about it. Just follow the video I'm making now, and I'm recording this so you can watch it back and all that. So um, basically, what we're looking at is we have a folder uh, called Rio Edwards Kepler, and we can see I'm in the code tab up here. I'm on the main branch, so that's just by default, you have one branch and it's called main. That's your main branch. And it has a README file, which this is the text of your README file. If you have a project on GitHub, if you have a README file in it, it'll always display that here. It's a special file. And that goes for all coding projects ever. Every coding project um, likely has a README file. And what that means is it's for other developers, if you want to like look at the project, look at the code, the README file is where you put like all of the information about it. It's not code, it's just text for other people to read. So I could write whatever I want in this README file. But for right now, just by default, it says this. The language it's written in, it's called readme.md. MD stands for Markdown. So Markdown is a special type of not programming language necessarily. It's what's called a markup language, which, yeah, it's markdown, but the type of language it is a markup language, which is kind of funny. But um, markup, as in it's not plain text, it's text that has some styles to it. So you can have headings. So doesn't matter. Doesn't really matter. Okay. Next part. So we made this repository. It has our single just README file in it, and that's all. It's basically empty, except for that one file. Um, Copy the repository you just created in GitHub to your local computer by following these steps. On the main code page of your repository, click the green, in my case blue, code button. I'm going to click that. And select SSH as the local clone type. Oh, I should tell you. There are some prerequisites, things you need to have done. Uh, let's see, where is it? The Odin project. So anyone who's been using Scrimba so far, Scrimba's great. So is the Odin project, except for, you can use one or the other. But this week it has to be the Odin project. You have to go through these, and specifically you have to do setting up Git. This link right here. So I'm just pausing to say I have already gone through these things on my computer, setting up Git on my computer. You will need to go here and do these. You'll need to do install Git on, for me, it's Mac OS. And you have to run some crazy commands and do some things that you might not have ever done, which it's fine. You do these once and you never have to do them again. And they're listed here. The steps are pretty straightforward. You might run into an issue. They don't have a version for Windows users, but we do have a link, I think, somewhere. If you're on a Windows computer and you are not being helped by this, then go to our Slack channel, go to Kepler announcements, and we'll have like a guide for Windows users because for some reason they don't have one on here. But anyways, yeah, you have to set up Git first on your computer, just like the program itself. Um, so assuming that is done, you can be following along from there. We're going to clone that repository that I just made on GitHub. We're going to clone it to my computer. And clone does what it sounds like it does. It makes a copy. So we have a version on GitHub, and like I've been saying, we are going to have like a kind of mirrored version on our computer. And the code that we write is just going to be on our version on our computer, the clone. And anytime we want to update the version on GitHub, we will push those changes. So for right now, we made a new repository on GitHub, and we're going to clone it to your computer. So, okay, sorry, that was a little aside, but back to where we were, we're clicking that green code button. Um, your lesson walked you through how to set up an SSH key with GitHub. Don't worry, if you followed those steps from earlier, you will have done that. You should select SSH as the local clone type. Lots of words, don't worry about most of them. I didn't understand most of these when I did this, so don't worry about it. Click code. You have to have gone through the setup steps, but click SSH and then copy this. So this is a command that you're going to run in your terminal here. And that command is basically telling Git, I want to make a clone of this specific repository. So it's like a URL to the repository. So I hit code, SSH, copy. Now I'm going to go to my terminal. If you don't know, your computer has a terminal. If you want to go to it, you go to your applications folder and search terminal. Every computer has one. For Windows or Mac, they'll have one. I have a special one called iTerm2, which is just slightly better, but it's not important. It doesn't matter. I still have normal terminal too. Do either one. Terminate. Okay. So I'm going to paste this thing that I copied from GitHub. And what this is going to do is it's going to, oh, wait, I want to make sure I'm in the right spot. So whenever you open a terminal, which this is another thing that you're going to learn in this lesson, it's probably going to look like a lot because I'm going to be doing terminal stuff. But there's only a couple commands you really need to know in order to get through this lesson this week. Please learn that stuff. Like do the material, learn what commands you need to run. Learn kind of the basics of the terminal, like what we have in the lesson material. You actually do need to know this stuff. So there's a couple different commands that you really need to know. And just on a high level, the terminal allows you to do things on your computer that you can't necessarily always do with pointing and clicking. It's like a easier way for programmers to make your computer do stuff without having to make a whole like graphical interface. It's easy to write programs that do stuff if you don't have to worry about writing an actual like interface for them. Like, so programmers use the terminal and you just have to get used to it. You have to know at least some of the terminal. That's where you're going to be using Git. All of your Git stuff is going to be in the terminal. You're not going to be necessarily writing code in your terminal. You're going to be using a code editor called Visual Studio Code, VS Code. What is the difference between console and terminal? Good question. There's none. Not really. Not that I know of. There's a bunch of terms that are very similar. So you'll hear console, terminal, command line, shell, bash, kernel. It's all the same. I mean, there's technically differences, but for all of you, it does not really matter. Terminal, console, it's all the same. Okay, so in my terminal, when you open a new terminal, it is kind of like in Finder, or if you're on Windows, the File Explorer. Uh, when you open your Finder, your File Explorer, or whatever, same thing when you open a terminal, you're in a certain folder. So there's like a context where like this terminal is in a specific folder. Um, so you can print the working folder, which in programmer terms we call folders directories. I don't know why, but print working directory. So directory equals folder. So pwd, you can run that. That prints the working directory, which says, where am I right now? What folder am I in? So I'm in a folder called users, which is like, that's like a system folder. Don't worry about that. And then Rio Edwards. This is my folder, my home folder. And we can change into a directory. So cd space, and then I'm going to change into, you will change into whatever directory you want. You'll figure this out through the lesson. I am storing my stuff for this time in documents ctd, code the dream, / Kepler, if I have a Kepler folder. Looks like I don't. So I'm gonna have to make a Kepler folder. And you're gonna get to see how I do that. So I can make a folder I can like navigate through Finder and point and click and make a folder. I can also do that through the command line. So I'm gonna do that through, or the terminal. I'm gonna do that here. So I'm gonna run this command, make dir, make dir, which, or mkdir, make directory, which a directory is a folder. So I'm going to make a new one in this current place I'm in. I'm in documents, code the dream. I'm going to make a new folder called Kepler. Make dir Kepler, and then I'm going to change directory, cd, into Kepler. Perfect. And if I can actually do open dot, that'll open this folder in Finder. So I just made a folder, and here it is in Finder. So you can make it in your terminal. So I made it in my terminal. And this terminal is currently in this folder, which is good. This is where I want it. Because now I'm going to run that command, this one, that I grabbed from GitHub. I'm going to run that in this folder. And the reason I made a folder and navigated into it is because this is going to make your code repository, your project that you're going to be working on all term. It's going to make it wherever you are in your terminal when you run this command. So I didn't want to just make it anywhere. I wanted to go into a specific folder to make this folder. Oh, okay. Getting an error. Let's see. It's good. I can do some live troubleshooting. Um, Copy and paste it again. Oh, sorry. I forgot. Okay, it's git clone and then you paste that. There. Okay. Yeah, so git clone and then you paste that. That's what you do. Perfect. Okay. And then I'm going to cd into that new folder, which it's called Rio Edwards Kepler. I can press tab. I think all terminals do this by default. You should be able to, if you're in a folder, you should be able to press tab to autocomplete, or if you type in a command, it'll autocomplete. If there's multiple options, it'll give you those options. Tab for autocomplete in the terminal. Remember that if you want to save time. Doesn't really matter. It's not important, but okay. So I just changed into this directory, which again, I'm doing this in the terminal. The only part you really need to do in the terminal is you need to clone it in your terminal, but you should be doing things in your terminal. So I changed directory, I navigated into this new repository that's on my computer now. So I cloned it. What this did, it's a bunch of stuff. This is like, I downloaded this file or this repository right here. So now this thing that's on GitHub, it's on my computer now. And I can actually go in Finder and look, it's right here. And there's that README file. So running that command pulled this folder and all of its files, all of its one file, onto my computer. So now I have this. And not only that, but it's being tracked by Git automatically because I made it on GitHub as a GitHub repository. It's automatically like working within the GitHub context. And if I clear my terminal, if I type ls, that lists the current files. If I type ls-a, that lists all the current files and all the hidden files. And look at that. There's a hidden file, which there's hidden files. That's a thing. There's a lot of hidden files on your computer at all times. Um, and every hidden file starts with a dot, at least on Mac. I think it's the same on all computers, but if you want to hide a file, you can have it start with a dot and it'll be hidden. So I just listed all hidden files and look at that. There's Git. So there's a folder. It's not a file, it's a folder. Git.git is a folder that exists as a hidden folder in every Git directory or Git repository. And you don't need to bother with it. Actually, don't do anything. Don't touch this. This is bad. It's hidden for a reason. Like I can't see it right here. I think I can actually press Shift Command dot. Yep. Shift Command dot on Mac, and that will show you hidden files in Finder. So there you go. My hidden Git folder right there. And it has stuff that you don't want to touch at all. This is under the hood. Don't even the programmers who have been doing it for 1,000 years, they don't touch this stuff. They don't know what any of this is. Don't touch that. It's bad. Um, is this Linux? Are you using Linux on Mac? So I'm using Mac, but Linux is, for anyone who doesn't know, there's Mac and there's Windows, which you know, those are operating systems. There's a third one called Linux, and Linux is the one that a lot of programmers use. Not all, like lots of programmers use lots of different, plenty of them use Mac, plenty use Windows, but Linux is an operating system that's like for people who want to, I don't know, spend a lot of time, like it's really like configurable. It's really good for programmers, basically. Um, and no, this isn't Linux, but when you're typing commands, um, you're using Unix commands, which Mac OS and Linux, the operating systems, they both spawned off of one uh, kernel called Unix, which is like a set of commands. So yeah, Mac and Linux share most of their commands. Windows shares most of them too, but uh, under the hood, Mac and Linux are very similar in the way that they actually do all this command and terminal stuff. So uh, yeah, if it's technically not, I'm not writing Linux, I'm writing a language called Bash, which is a scripting language, born again shell. Um, I'm saying a lot of information that none of you need to retain right now. So um, uh, I guess the one nice thing to know about that is if you want to know how to do something on the command line in the terminal, look up how to do it in Linux, because that is how you will get the answer. Because technically, no, I'm not using, this is not Linux. This is writing uh, commands using a shell, which is a shell over Unix, all this stuff. But uh, technically, it's mostly the same as Linux commands, and everyone who uses Linux is pretty much always writing commands in their terminal. That's like a big thing in the Linux world. So if you want to learn how to like make a file on Linux or make a folder, say make a folder, you'll see make dir, which if you remember, that's what I just ran. I ran make dir. So It's not Linux that I'm using, but they share all pretty much all the same commands. And if you look up how to make a folder on Mac, you're gonna get like, oh, go to Finder, right click, and all that. So yeah, if you want to find commands, Linux users are always using commands. So and they're shared between the two for the most part. Um, do we need PowerShell for Windows or command prompt is good enough? Uh, I think I think what you need is Git Bash. I think for Windows you need a program called Git Bash. So so this is Git's website. You'll go here, you'll click on Windows, and you'll download one of these. You'll probably have to look up, is your computer 32 or 64 or whatever, um, if you don't know. But this, yeah, this is technically you're downloading Git, but what you're downloading, I'm pretty sure when you click on one of these is uh, like it's like a terminal that's built for Git, uh, and it has all the same commands that we're going to run. Um, from the way I understand it, I don't use it because I'm on a Mac, but I think that's what you do. Okay, where were we? Oh, I think I might have had one more chat. Oh, no. Okay, totally lost my place. Okay, we were we just cloned this new repository, which is great. And look at this. I have my I have my terminal configured to do different things, but uh, you should see something similar, I think, but uh, I'm not sure if it's default. But you can see right here I have main, and then this little branchy thing and that little guy. Zoom in a bit. Um, Main, this says I'm on the main branch. I can check anytime I want. I'm on the main branch. And then this is so I'm in a Git repository, and you can actually check to make sure you are by running git status. So git status, I'm on branch main. Your branch is up to date with the origin branch, which is on GitHub, origin/main. Nothing to commit, working tree clean. Uh, your working tree is the version of your files that are like not uh not committed or stashed or not committed or staged or stashed. It's like the current version of your files is your working tree. So if it's clean, that means that it lines up exactly with there's no uncommitted changes. If I made some changes, then it would be uh, a dirty working tree. Okay. Well, let's see. Okay, so we cloned this. So now I have that repository on my computer. Um, yeah, pasted this command, git clone, and did that. Go to your IDE terminal or your computer terminal. So I've been in my computer terminal, but I'm going to start using my IDE terminal, which we're all using Visual Studio Code. So I'm going to pull up Visual Studio Code. As part of this lesson, you're going to be downloading this uh, code editor here called Visual Studio Code. Um, and what this is so we have the terminal and then we have your code editor. And your code editor this is where people write code. They use code editors and uh, they're also called IDEs. There's a subtle difference between IDE and code editor. It doesn't really matter. IDE stands for Integrated Development Environment. Um, Technically, the difference is an IDE is usually more batteries included. So an IDE will have like a bunch more stuff, whereas a code editor is more bare bones and you kind of can configure it how you want. So VS Code, you're going to download, you're going to be using it, we're all using it. This is where you're going to be writing your code from now on. And it is going to look pretty similar to uh, Code Sandbox. They actually use like the same type of interface. Um, so it should feel a little bit familiar. Um, this is your program where you're going to be writing your code, and you can also run commands and some other stuff in it too. And it's great. There's some setup you're going to want to do, and that's part of this lesson. I won't walk through that, but I do have a video that you should all watch. I have a YouTube, and I have a video on it that from like I've have a bunch of previous Code the Dream recordings. So you all should check out this one video I have if you want. Um, how to get things done on your computer. This one. You're being more productive on your computer. So I'm going to link this to you. In this, I show uh, how I like to set up my VS Code. Maybe I'll link it in Slack. Right here. You don't have to watch it, but there is a video as part of your lesson this week that will be showing you how to configure Visual Studio Code. Uh, but I have some specific things that I like to do. So just in case you want to match my setup. And there's some other cool things in there too, tips for things and stuff. Okay. So we're opening up your IDE, Visual Studio Code. Where are we? Yep. And then we're we're gonna want to now, or we're gonna want to open the specific repository that we just made. So I'm gonna do open. You can do file open, or there's a bunch of different ways to open a file, but navigate to the one that says your name slash Kepler. And it's going to give you a big pop-up that says, do you trust the authors of this folder? Yes, I trust the authors because the author was me. Okay, and now we have the welcome screen. We have my README file here. And this is your coding setup for the next however many weeks. So get used to it, get comfortable in it. It's going to be where you're writing code now. Okay, so your code editor, Visual Studio Code, has its own terminal built in. So make sure you're in the proper directory where you want to create and store files for your work. So, oh, and this is where it's saying run your git clone command. I did that already. And then I opened VS Code in the correct folder. By the way, a lot of people accidentally open VS Code in the parent folder on accident. So they will do this. Show you just because a lot of people make this mistake. They'll go, okay, Kepler, that's what I want to open. Then they hit open, and then you're not in the correct one. You want to open this one, the one that's your name dash Kepler. Because if you open this one, whenever you try to run, you open your terminal and you try to run commands, you're going to be running them in this folder, which will make Git not work. I see lots and lots and lots of students run into that issue. So make sure you open the right folder. Because if you open the right folder, you can go to terminal, new terminal, and this will automatically open a terminal down here that's already in the correct folder. It's in the folder that you want, and I can run git status, and it'll give me some information like that. If I open that parent folder, which I'm just going to navigate to the parent folder and then run git status, it's going to say fatal, not a Git repository. So if you see this, you probably opened the wrong folder, or for whatever reason in your terminal, you're just not in the right folder. So I'm going to cd back into the correct one, git status, there I am. Okay. So we did that. Create a new branch to house the work you just, okay, so we're finally doing some like actual Git stuff. Sorry, I tend to ramble. Create a new local branch to house the work you just did for this assignment. Oh, wait. Uh, where's the part where you're supposed to write code? I'm not seeing it, but oh, wait, no, we create the branch first. Sorry. Um, yeah, so we make the branch and they just tell you the command to run right here. It's git checkout dash B. And if you remember, checkout is the command that if you do checkout dash B and then the name of a branch, that is how you make a new branch and switch to it. There's another way to make a branch that doesn't automatically switch you to that branch, but checkout is the best way, the easiest way to just make a new branch and switch to it. So we're running this. Cool. So we switch to a new branch called lesson 5. Perfect. You can see right here, lesson 5. If I run git status on branch lesson 5, which is great. So we made a new branch. Cool. Now open up the README file and add your full name. So here we are at that README file. I'm just gonna write Rio Edwards. Look at this. GitHub Copilot trying to write a whole paragraph for me. Amazing. Okay. Uh, by the way, if you're using AI for your work, that's great. It's awesome, but definitely like limit that as much as you can because uh, once you get to the advanced classes, you will be not loving life. So definitely like limit your use of AI because you need to understand what you're actually doing. Um, and I can turn off Copilot. Uh, how do I do that? Completions. Yeah, disable completions. There we go. Perfect. I don't know if it's on by default. Oh, there it is. Going again. Let me go down here. Turn it off. Okay. Create a new file, same level as your README file, and title it index.html. Okay, so we're making a new file called index.html. There's a couple ways you can do this. You could do it in Finder or File Explorer or whatever. I could just, or wait, you can't. At least in Mac, you can't just make any old file. You can just right click and go make file. Um, because files are specific types of files. You could use text edit to make a file, but when you're a programmer, you can do all this cool special stuff. So I can make the file by right-clicking in here and saying new file. That'll make it just at this kind of root level of my thing. So you'll end up with like folders and stuff, but right now this is all my files, my one file right here. This is your File Explorer right here, and you make sure you're on your Explorer tab up here. So Explorer tab, here's my files. This is your open editors. So this will be any tabs you have open. So you can have multiple tabs with multiple files open. Uh, they're showing the same file twice, this README file, because this is showing all my files. This is showing the tabs I have open, and I have this tab open here. So in all my files, I can right click and do new file, and I can do index.html. Enter. Uh, so that's one way to do it. Another way is you can use your command line. I'm going to show you how to do that too. Touch index.html. Touch is the command you run to make a new file. So I made that. And that was all the coding for this week. Just wrote your name, made an empty index.html file, and we're good. Amazing. Okay, so now we need to do more Git stuff. So uh, make sure your code gets copied to GitHub by adding the changes, staging, committing them, pushing them to GitHub. So the flow is add, commit, push, ACP. I should come up with like a mnemonic for that. I don't have one yet. If anyone can make a song about it or I don't know, some way to memorize it easily, but ACP, add, commit, push. So you add your when you add, you stage your changes for the commit. So you say, I'm going to add all the changes that I made, which I could selectively say include these changes, don't include these ones, but generally you want to add all of them. So git add, I'll do that here, git add, and you can do dot. Everyone does dot. That's what they teach you in the lessons. I do dash A because dash A is technically better. So git add dash A stages all my files. And we actually have a source control tab over here. You can click on that. And this is your Git tab. This actually shows you Git stuff. So you have your commit button. You could just do that through here, but it's best to do it through the command line so you can get the experience with that. It's saying we have stage changes. So I just staged both of these. Before I did this, they weren't staged, and I can actually unstage them. Uh, how do I uns? I think it's git reset. Yep. Okay. So here's my changes. I'm going to run git add dash A, and now they're staged changes. So they're staged, which means they're all these changes I made, the adding Rio Edwards and adding this new file, syntax.html. Doing those things, those changes are now going to be recorded in my next commit. So git add dash A. Next one is git commit dash M. And then the message that you want to leave for this commit. So I'm going to say, well, my first commit. Cool. So that was it. I did git add, stage the changes, git commit with a message, my first commit, and I saved my place. And there's no confetti or anything. It's Git is very like it's all just happening behind the scenes. Like you don't really see what's going on, which is probably why it's so hard to learn because it does a lot of stuff without showing you visually what it's really doing. But we could see it down here. My first commit. If you open your graph, show that. Or wait, this might not be there by default. I think it's not. I think I have it because I have an extension called Git Lens. You can install extensions. Git Lens is good. Um, okay, now we added the changes, we staged them, or yeah, staged them, we committed, and now we're gonna run git push origin lesson 5. Oh, okay, git push origin. Actually, I think it's supposed to be dash U origin lesson 5, right? I think it should be, but we'll see. We'll see what happens. Okay, it's fine. I was wrong. Oh, wait, no. I was right. Or wait, no, I was wrong. Okay. Don't need dash U. I don't know. I don't know why I thought you did. I guess you don't. Git push origin lesson 5. Okay. Yeah. And that means that they did update the curriculum. So they are telling you to do more than just git push. They're telling you git push with the extra information you need, which is good. But then they tell you what to do if that doesn't work, which is good. Okay, and that was it. That was all. So that was all the Git stuff. So we um, cloned the repository with git clone, and then we made a couple changes. We added our index.html. We added our name to the README file. We staged the changes with git add -a. We committed them, git commit -m, my first commit. And then now our local version of our code has this new branch with these new changes. Now we need to update GitHub with whatever we just did. So I'm going to do a git push, or wait, sorry, we did just do a git push. So our GitHub should be updated. So I'm going to go back to my GitHub and there we go. On GitHub, now we see lesson 5 had recent pushes 2 seconds ago. So that means GitHub is now aware that we have this new branch that we just made on our local computer. And they're saying you just pushed this to GitHub now. So GitHub has it. You can see that by clicking here and seeing view all branches. Lesson 5 now exists. And it's giving you this option, create or compare and pull request. So that's what we're going to do. We're going to click that and make a pull request. When you create a pull request, remember this is the thing that you're going to like, it is like a staging area before you merge, basically. You're saying, show these two branches and what it's going to look like when they merge so that someone can come and review all the changes between them so that your reviewer can go and review your pull request. So we are making a pull request right now, but you actually have to click create pull request and then add a title and description. Let's see, do they have information on what you should do? Yeah, so create or compare and pull request. Feel free to put any notes. Don't worry about it though. And then click create pull request. So down here, create pull request. And there we go. The pull request by default, they just loaded up. The title of my pull request is going to be the name of the commit that I did, which doesn't really matter, but and there it is. So here's my commit, my first commit. And if I click on that, it's going to show me the files that I changed in that commit. Here it is. So there's a little plus next to index.html, which means I added a file. And then this means I modified that. You don't have to worry about any of this, but these are the changes I made. I made a README file, or I know I updated the README file with my name, and then I created an empty index.html file. And I have this funny AI tool that I was playing around with called CodeRabbit, which you will not have, but it's this goofy thing that, or it's actually a useful thing. I'm sure this is like a tech startup that's making a bunch of money off the AI boom. But they they have this thing that uses AI to summarize your pull request automatically. So it's saying currently looking at your PR and commits, and it gives me a little guy, and then it actually, I think it usually, uh, yeah, it gives me some tips. You're not going to see any of this. I'm just showing you this is something that's funny. It actually will write me a poem, an AI poem that summarizes the changes I made in my files. So anyways, okay, that's pretty much it. So when you submit your assignment, what you do is you go to your, uh, by default, you'll be here on this pull requests tab after you create it. If you're not, then go to your pull requests tab. So you go to your repository right here. Then you go to your pull requests tab. Open this pull request, which you should already be there, but in case you lose your place, that's how you get there. Copy this URL up here. And when you submit your assignment, you're going to paste that URL. into the assignment submission right here. That is the URL to your pull request, which is the code that it's not just a link to your code, it's a link to the updates you made over the past week. So each week when you submit your pull request, it's going to be a quick way for your assignment reviewer to see what changes did you make over the past week, which is nice because you can see, okay, you know, you can ignore all the rest of the code and just focus on the parts that changed. So that's what a pull request is. And you're going to do this here for your assignment review. And this perfectly mirrors what you see in the real world at like real companies when you're submitting code. And the pull request is just a URL, and I'll post it in the chat. Anyone can go to that. Anyone can see my pull request and comment on it and tell me, this is great code, you did amazing, or this is terrible. Okay, that's the end. That was how you do the week's assignment and all that stuff. So thank you all. Looks like I have a question. What is the shortcut for DevTools in VS Code? DevTools. Do you mean the terminal? DevTools is a thing in Google Chrome or in like a browser. I use F12, which on a Mac you use FN F12. That's what you're talking about because this is what DevTools is technically. So um, if you're talking about the terminal, then I think I configured mine to be different. New terminal. I change all my hotkeys up because I like to, but I sometimes don't remember what the original ones were. So, but you can always go up to terminal and you can change your keyboard shortcuts. See, I have my keyboard shortcuts like this is uh, Control, Command, Shift, or wait, Control, Option, Shift, wait, Control, Command, Shift, Option, K. That is my keyboard shortcut. The reason is because I set up what's called a super key, which means my I can press one key. I can just press my caps lock key. I disabled caps lock on my computer because I would rather use that key for a super key, which means when I press caps lock on my computer, technically it's sending the key codes for all of those different key codes, which means any key binding I set is now free if I use the super key. So I can hit caps lock K, and that does all that, or caps lock E, and it does all that. So I don't even think I talked about that on my productivity on your computer video, but I have a passion for learning shortcuts and ways to do things faster and efficiency on computer stuff. So if you ever have any questions about that or want to nerd out on that, hit me up. Okay, that was really long, been rambling. Bye everyone. Thank you so much. I'll be posting this recording and the slides and all that. So if any of you are having issues or need help or whatever, just feel free to reach out on Slack or whatever. Okay, bye.
Thank you, Leo.